All right, so now that we've gone over a little bit regarding the theory of Fischer esterification as well as talking about combinatorial chemistry, what I'd like to do in this video is go over a little bit of the practical details associated with the Fischer esterification reaction that we're going to be doing this week in lab. All right, so this is experiment 4. So there's 3 things that you're going to have to add into your reaction mixture. All right, you're going to have to add your alcohol, you're going to have to add in your carboxylic acid as well as a mineral acid to help catalyze the reaction and push it to go forward. Now we're also going to be doing an excess of one of these reagents. So we said that we're going to need to push the reaction using equilibrium so we can swap it with starting material, and that will drive the reaction to product. We could also have taken away water. We're not going to be doing that today. All right, so we're going to have one reagent in excess and one reagent kind of functioning as our limiting reagent. Now, the nature of which one it is has been provided to you. So hopefully you know which one it is. The smaller starting material is going to be the one that's going to be your excess reagent, usually because it's cheaper. And for us, it's going to be easier to remove as well. All right, so what I'd like to do is I'd like to basically put together how you would do this. So you take your reaction flask, and I think you're probably looking at a 100 ml round bottom is probably going to be a safe bet. 50 ml might also work. It depends on whatever volume gets you below halfway filled. All right, so that's really important. All right, so you're going to take your round bottom, you're going to put a stir bar in it, and then you're going to add in your alcohol and your carboxylic acid. Now I'm going to warn you right now, your carboxylic acids are very, very smelly. All right, you should be wearing gloves when you deal with the carboxylic acids. They will be in hoods. There'll be one up in the front hood, but there'll probably be a couple others scattered throughout in some other hoods. They need to stay in the hoods. If they come out of the hood, the entire lab will start to smell, and actually the entire building will start to smell. So please do not take the carboxylic acids out of the hoods. There's going to be a graduated cylinder right there for you. So you take your carboxylic acid, you take your graduated cylinder with gloves on, you pour the carboxylic acid into the graduated cylinder. All right, you have your round bottom ready to go, you pour your solution in, cap it, and then take it back to your hood. Also, when you're done with your carboxylic acids, take off your gloves and leave them in a container in this hood. All right, so just take them off, throw them in. I will dispose of them later. All right, do not throw them in the garbage, or else the garbage will start to smell, and then the lab will smell, and then the building will smell. Everything with the carboxylic acids needs to remain in the hood. All right. The alcohols do not have nearly that bad of a smell, so they're going to be located throughout the lab, usually in an open space. So again, weigh those out, measure those out in the exact same way that you measured out the carboxylic acid, but you don't have the same issues associated with the smell. All right. Once you get those 2 things together, you're then going to add in your mineral acid. So we've got concentrated sulfuric acid that you'll be adding in. All right. And weigh that out with a pipette, put it in, get a reflux condenser on your reaction, get some water tubes going in and out, set the condenser, set the heating mantle to about 2, and then you're going to run your reflux. Now it says to run it for about an hour. We're probably going to cut that down to about 45 minutes. All right. The other thing is, while that reflux is going on, you still have to do experiment 3 NMR. So once the reflux is running, come up to the front, grab an NMR tube. You've got your product from last lab, and what you're going to do is you're going to weigh out in a test tube probably about 30 to 50 milligrams, 0.03 to 0.05 grams. Weigh that in a test tube, dissolve it in chloroform, and then add it to your NMR tube, and you'll be ready to go upstairs and have the NMR run. After the reaction is over, I'll be back in lab and we'll be able to discuss this, but what you want to do is proceed with the workup as it's written. I'm not going to go over that in this pre-lab. You should know how to do that. All right? But make sure you know which layer is which. You have a water layer and you have an organic layer. Now the organic layer is really composed of your ester, and that's it. So you might want to know the density of your ester. And if you need to know how to name that, we'll go over that in 1 second, so you have that information. All right, so you need to know the name of your ester, the density of your ester, and even if you don't know the density, you can probably get an idea of where that layer is going to be. All right. So just make sure you understand what kind of smell as well, and we'll go over that in 1 second. All right. So hopefully that covers everything we need to know about the practical aspects of this lab. It's pretty straightforward. But again, to recap, what's the important issue? Carboxylic acids that we're going to be working with are very, very smelly, and they'll go with you when you go back to your dorm or back to your house. It certainly is a smelly chemical. So keep everything in the hood. Nothing gets washed in the sinks until those compounds have been completely removed. All right? Okay?